Hi, welcome to this Programming for Cultural Heritage demo video. Today we're going to look at working with files that you're retrieving from an API or a website and how you can kind of manage those files and how you can kind of store those to enable kind of these workflows that you might want to work for a project. So say, for example, you have a project where you're looking at a number of records from a resource like an API or a website, and you want to kind of iterate over those records and pull certain things out and do certain things with various fields. So you can imagine maybe it's a cultural heritage thing and there's an API that returns a bunch of records for items. And you want to have a bunch of those items, you can have hundreds or thousands of those items, and you want to compare something like size or subject headings or some other sort of field on those various items. So today we're going to look at kind of like how you'd enable that. How would you first retrieve those items, store them locally, and then kind of what kind of workflow would you have to able to do that? So we're going to be working with APIs today. We're going to be using the Glob library to iterate over files, and we're going to be looking at like how you can pull data out of sites that are semi-data based and sometimes semi not. So we'll be looking at APIs and this sort of quasi data area. So this would be a useful video if you're trying to, work with a lot of JSON files or work with a lot of XML files that you're retrieving from a website or an API. So to get started, we need an example of something to do. And so I thought we could just use this Harvard API that is available. And so this API just returns information from a few of the Harvard art museums on the campus there. And so if we go to, you have to request the API key. So I've done that and I have the key. And then you have to go to their documentation and learn about their endpoints, right? So this is tied into the API lecture. So, we go into much more detail about this in that lecture. But for example, if we wanted to just do some, create a imaginary kind of research question around, say like gardens and plants and trees or something like that, we could try to find items related to the topic that we're interested in, and then we might want to kind of iterate over those objects and kind of do some sort of analysis of that. Um, there's also something like medium, right? So let's see what this medium is about. So medium will return mediums about certain types of mediums, so materials. So, you could get information about all the watercolors here. So medium ID is 20, this large number, and that returns all the watercolors in a collection. So you could say, I'm really interested in analyzing all the watercolors that they have held at the various Harvard art museums. So let's try to go down that route and see if we can do something like that. So we're going to want to return objects, and we can see that the object's endpoint has a number of fields that you can pass to it, and one of them is the medium key. So you can send the medium ID or pipe separate list of medium IDs or medium names or pipe separate list of medium names or any. So you could potentially say, okay, I want to see all the objects that are watercolor based, right? So let's get started with this and let's write our script. So we will move to our downloads directory, and I'm going to make a directory called Harvard Art. And so I'm going to go into that directory, and I'm going to Sublime. So I'm going to make a new file called download items.py. And so in here, we're going to be talking to the internet. So we're going to import requests. We know we're going to be using JSON because we know the API is in JSON. So we're going to import the JSON library. And so now we need to set up talking to their API. So one thing I know for sure that we're going to need to use is their API key. That's one of the required things. And so I have an API key, but I don't want to just kind of like paste it in here. I could just do this, right? API key equals, and then put my API key in here, but then it would be public and everyone can see it. So I'm actually going to go kind of try to hide it a little bit so it just doesn't appear on the screen. So I'm going to go back to my directory and I'm going to make a new JSON file called key.json. And I'm going to say, okay, this is going to be a dictionary, and there's going to be one key value pair called key, and then I'm going to put my key here. And so now I'm gonna actually paste my key into this off screen. But before I do that, let me just kind of demonstrate what we're gonna do. So I have my keys potentially stored in here. So I have a bunch of X's there stored as the key. What I can do is say, okay, now I'm gonna open that file called key.json that's in that directory as key file. I'm going to say key equals, I'll say key data equals json.load and the key file. So basically, I'm storing that my key in a JSON file, and I'm opening it here in Python, and I can just print out just to see if it works the key data. So now we should potentially see that the key is the key dictionary that we just made in that JSON file should print out. So let's run it. And you have to spell JSON right. JSON. All right, so if you spell JSON right and run it. All right, so we can see that the key data is printing out there. So then I could just do something like this. I could say API key equals key data, and the JSON file, the key is key. So I just say key, and then I could print out API key. And there's my key, right? So now I'm going to go to that file and change it to be my Harvard Art Museum key that I requested for real. And again, the only reason we're doing this is just so you can't see my key on this video. If if I didn't care about that, I could just hard code my key right here and just change this to whatever my key is, right? All right, so now that we have that, we can start setting up our talking to the API, right? So we know when we talk to an API, we need a base URL. And so if we look at the objects endpoint here, it says the object endpoint is /object. And so we can see some examples here. So I have an example here with different options there. So we know the URL base is going to be at least that. And then we can do our payload or parameters. And so again, this is just a key value pairing of the things you want to pass in the URL, right? So every time you pass something like the API key, something, and keyword equals something, right? You can simplify this by just putting this into the payload or the parameters and pass that directly to our request things, and then it builds out the URL for you, and you don't have to worry about, structuring the URL. So we know for sure we need to pass the API key. That's one of the required keys or values you need to pass. So it should be API key, one word. And that's going to be my API key that I've imported from the JSON file there. And now we need some other way to limit the query. And so we had a couple ideas, like maybe around keywords, and then we kind of got into the idea of medium. So let's try medium and say watercolor and see if that returns anything. And then we need to make the actual request, right? So we can say results, or we can store r equals requests dot get. This is a get request. We're asking to get this URL, and we're passing the parameters that we stored in our variable called params. So when that comes back, we're going to take the data out of it by using JSON to loads the result from the API and turn that text into a Python result data type, a Python dictionary. So let's just print this and see if we get anything back or an error. All right, so we got no records back, it looks like. So maybe the medium is not right. Watercolors, maybe. No, so we actually have to, what if I change this to oil? No. So we probably need to go figure out like what that number is for different mediums. And I know in the medium endpoint, they gave an example that watercolor is a specific ID. Like watercolor is this long number. So let's use medium. Let's change the medium from this keyword to this number and see if we get any results. All right, so that's better. So it says there's total records 2,482, and that there are 249 pages because there's 10 in each page. Um, let's see, maybe we want to use another medium too. Like we want to use something about, maybe watercolor and oil paintings or something like that. So we need to figure out what the other mediums are, or what the other medium IDs are if we wanted to do that. So we need to get the medium ID somewhere. So what we can do is, if you ask just this one endpoint, it will return all the mediums. So let's just quickly do that. We'll just comment this stuff out really quick. And we're just going to redo this, change this to medium. We still need to pass the API key, but that's all we need to pass. And then we're going to see what it prints back. All right, so this is all the mediums. And actually there's total records is 10 per page, and there's 270 records. So there's 28 pages. So let's look at this documentation really quick. And it says you can increase the size. And I just happen to know you can increase it up to 100. So let's just increase up to 100. And we can say the data stored in this thing called records. So we could say for medium in data records. And then we're going to print medium. So let's just do this, and we'll pick a bunch of mediums that we want to use. So let's just print the medium ID and the medium name together. So we'll say print the medium name, and then print the medium ID, medium ID. All right, so we have a bunch of mediums here. This is only the first 100, but we'll just pick a few of these, right, that we're interested in. So maybe we're interested in like red chalk. So let's make a list of these mediums I want. Kind of weird variable name, but that's okay. So we'll do that's chalk. And we're gonna do watercolor. It's from before. Let's do colored pencil. Let's do ink and mica. That's fine. Whatever. I'm just picking kind of random ones. You probably, you'd have a different kind of question than I'm just going through and picking random stuff. But there's watercolor. We did that already. How about graphite? And let's pick one more. Let's do acrylic. So there should be a lot of stuff, right? So these are different the mediums we want. So we can get rid of this medium code because now we have the IDs and we can get rid of it. All right, so what we can do now is go back to our current code, and we're passing just as one medium again. And let's just run it again and make sure it works still. So it works fine. But here let's see how many results are coming back. So we'll just print out the total records that's stored in that key there. All right, so couldn't find that. All right, so I'm gonna run it again, see it holding again. Oh, okay, so there's a field called info first, and total records is stored in the info key. So we have to say info and then total records. All right, so there's 2,482 mediums or objects that have the medium watercolor. If we look at the documentation again for object, it says supposedly for medium ID or pipe separate list of medium IDs. So when they say pipe, they mean this character. So if it's true, then I should be able to say, okay, we're passing this as a number right now, but we could also pass it as a string apparently. Let's see if it says that's fine. Everything's a string on the internet when you pass it through the URL, so that's of course it's fine. But let's try to pass two of them together. We're separated by a pipe and see what it does. We should potentially get more than the 2000 number. 2790. Let's pass it another one. All right, so it's going up, right? So every time we add one of these, it goes up. All right, so what we can do is we could hard code it like this, or we can make we can use there's a method built into strings called join, and it joins a list into a string based on the delimiter you give it. So we could call this medium IDs string. And to do that, you start with a string you want to join on. So we want to join it together with a pipe. And you just say dot join. And inside of here, you put the list you want it to join on. And that's the medium IDs I want. And now you just put that there. And let's just print this out to see if it works. All right, so expected string instance, and I found on line 10. I wonder if these need to be strings. I don't think so. I didn't think these had to be strings, but let's see what that says. Huh, yeah, I guess they have to be strings. Okay, that's fine. You know, we could use a string function to convert them to strings, but this also works. So I just store them as strings in the list, and then I use the join method on this pipe character to turn them into a joined string, one big string, right? This is just a string. And it ran that string through the API here, and it came back with 11,000 items. So now we have 11,000 items. Let's print out that information again. All right, so the info information, so there's records, there's 10 per page, so there's 11,000 records, so there's 1,000 some pages. And so what we need to do now is try to get this page count down so we don't have to do 11,000 or 1,100 requests. So we know from the previous docs, there's a size parameter that you can pass to it. And we saw that the maximum for the size before was 100, so we could say size equals 100. And let's run it again. So now we have the same total, right, but we only have 113 pages. So another nice thing that this API does is that it also gives you the page number you're on, and then it gives you the next URL that you want to use. So what you can do is just reference this URL that they're passing in order to kind of get to the next page that you want to work on, right? And they're just building the URL that you gave them, but for the next result set of pages. So for the only thing changing here really is page equals 2 instead of, you said page equals 1. So you could do this manually, or you could rely on their API next page. Since we know exactly how many things we need to use, we can just build it manually. So we'll just do that. Okay, so if we're going to build it manually, we need it to loop 113 times and increase the page by 1, and everything else stays the same for each loop. So to do that, let's make a little counter, and we'll set it to 1 to start with. We'll say while counter is less than or equal to 113, do this, and at the very end we want to add 1 to the counter. All right, so inside here we're going to have to recreate our parameters. But the only thing we're really changing, right, is the page. So we don't have that here yet. So just make sure the name of the variable is right, page. And then we can put that in there and set it equal to our counter. All right, so when this runs, it will loop 113 times and create the parameters there. And then we actually do the request here. The URL is still available to us from up here. And then we need to parse the data again. And here the data is stored in not an info, but in a different piece of it. So let's just print this out and see what it says. All right, so let's print it out and see if it works. Oh, but I don't want to print my key data. I want to print the data coming back from the API. So let's try it and see if it works. All right, so it looks pretty good, right? So there's the info one, have the information, and the rest is stored in records. So we can just do something with the records, and we can see the records is a list of dictionaries. So what we can do is just loop through them, right? And so each one of these will be one of the records. All right, so probably what we want to do is like, we're not really sure. There could be kind of overlap, right? You can imagine some artworks have multiple mediums and they have the same artwork has two or more mediums, maybe one of the mediums that we're actually using. So what we could do is save each one of these records out to its own file, its own JSON file. And then, if it already exists, it would just overwrite it with the new record from a different query. So we don't really know if it's kind of like collapsing all these records together or repeating them or whatever. And it could be that we're doing something besides medium, right? We could be doing multiple keyword searches. So we could potentially want to have, there could be duplicates in the search results, right? So what we want to do is just kind of like write out each one of these records to its own JSON file in a directory. And then we'd have all these records available to us and we'd be able to kind of loop over them and do something. So to do that, we need to first have a place to put them, right? So we need to make a directory in our folder. So right now we just have the two things here, so we can make a directory. And we'll call it records. And now we need to find some place to put them, right? Or some name to name them when we make them. So if we look in the record here, we'd want to find something unique that represents it. And so I can see here it has an ID. So ID is probably going to be a good unique identifier for that specific record, right? Because you would assume there's only one ID per record and they don't overlap. So maybe ID would be a good potential file name. So let's make the file name first. We could say file name equals record rec, and the ID is the stored in the key ID. And then we could say also add the letter JSON to it. So let's just make sure this works, and let's print out the file name each time. Oops. All right, so it says can't support adding integer and string together. So that makes sense, right? Because the ID is stored as a number in JSON. We just need to make it into a string. That's one way we could do it. We could also use F templates like this. And anything you put inside of these brackets, the variables, turn it into a string. And so this is basically the same idea. So let's try it that way. Oops, can't use the same types of quotes, right? So here, I'm using double quotes here. I'm using single quotes inside the variable key name reference. All right, so we have the file name. The next thing we can do is write it out to the file system. So we can use JSON.dump. And we need to pass two things of JSON.dump. We need to pass a file name, or sorry, the thing you want to dump, and then the file name where you want to put it. So the thing we want to dump is the record, and the place we want to put it is you actually have to open it up and point to it. So we want to open up the directory called records, and this is relative, right? If we did this, it'd be absolute, but this is a relative path because it's in the same directory. And inside the records directory, there's going to be a key or a file name, and we already have the file name ready, and so it goes there. And then the other thing we need to pass the open is to tell it to open in write mode, and then let's also just tell it to indent. All right, so let's try to run this. So this is going to go to 100 pages, so we'll pause and come back when it's done. All right, so finished running. It didn't take very long, just a few minutes. So if we looked into that directory, if we change directory into records, we could see all the files in there. So if we sublime one, you can see that's one of the individual records from the API, right? And so you might say like, well, why are we storing these as individual records? Wouldn't it be easier just to store them as like results, right? Like each API page, store that as a result because then you'd have 100 pages instead of 11,000 files. And it's true, but you could say like, well, what if I wanted to add another medium here, right? So say I came back and I said, I did those mediums, but now I need to add another one. So you could just basically simply add another one to it and comment the old ones out and run it again. This is the medium for like pastel or something. And if you ran it again, it would, oh, I'm in that directory. So I can go back one to the right directory. So if you ran it again, oops. So if you finally run it again, it would just do that second page, right? Oh, and here I didn't change the total pages from 100 to back to 2, right? Because medium has a different page size. And you can make that automatic, right? You could say like check the info piece here to pull out the number of pages. So you could do that first up here. So you could say you can make a new variable called max pages equals 0, and then set it equal to whatever is stored in the pages key of that first request. So now we didn't need a hard code limit total number of pages. It will just know based on that request. Let's try it again. Pages. It's actually stored in info pages, not just pages. Right. So now I just added another medium. I didn't have to download all the other ones again. It just kind of added them there. If there happened to be one already in the directory, you just overwrite it, right? And it's fine if it overwrites it because the records are the same coming from the server and they're just being stored in the same directory. All right, so now that we have them all listed there, we're kind of done with the script, right? We don't really need this anymore. If we wanted to add more later, we could do that. But now let's say we wanted to kind of pull out some information from all of our work, right? So let's close the script. We're done with that one. And we could figure out, you'd have to spend time and figure out what exactly you wanted from each one of these pieces of data, right? So let's look at one of them again just to get an idea what the structure is like. So you have a number of stuff in here, right? And you'd have to imagine not all records have all the same pieces of information, but there could be some similarities between across all of them. You'd imagine they'd all have some of them, some certain things like all have titles or all have dates, you know. So this one has a date start and a date begin. So maybe we could say like, I want to find the average date for all these materials, right? What's the average for them? All right, so what we could do is basically we want to open up all the files, right? Look for all the date begin keys if it has one, add those all up, and then divide by the total number of records there are. So then we could say, for these specific mediums, the average date of items in the collection is X, right? So to do that, we would need to be able to open up every one of these files, right, that is in the records directory. So to do this, there's actually a nice library that's built into Python called Glob, G-L-O-B. And so let's make a new Python script that is going to do this. So you can kind of see that we're kind of breaking our workflow into a couple of scripts here. One is to acquire the data, and then the second one is to analyze the data. So we could do something like, find date.py. So we're going to edit that file. And so these files are stored in JSON, so we're going to import JSON. And then also, like I said, we're going to import a library called Glob, G-L-O-B. And so what Glob does is it allows you to send it a path and then a certain kind of path, a file name path pattern, and it will return a list of those files. So for example, we could say for file in, and you say glob.glob. And you say glob.glob because glob is actually a function built into the library glob. So that's why you're saying glob.glob. This could be something called like find files, if that's what they called it, but they called it glob, the function. So it's glob.glob. And then you give it a path. So like a command line path of the files you want to find. And so all of our files are stored in the records directory. So we know that we're going to look in the records directory. And then we know we want to look for all the JSON files. So the file name could be anything, but it has to have the extension .json. And just to make sure this works, we could print out the file name. So we run this Python 3 find date. We can see it returns all of the file names for each one. And since we have each file name, now we can just simply open that file up and do something with it. So inside of here, we could say, okay, now that we have the file name, we could say, you know what, with open, and here's the file name as in file, or we could call it JSON file. We could say, okay, now data is going to be equal to the JSON library to load this file. And let's just print it to see if it worked. All right, so now it's going through the entire directory of JSON files, loading each one up, and doing something with it. So what we can do is we can see that this is a dictionary of keys, and the key we're interested in is the date started, date began key. And so what we could do is, you can imagine there might be some things undated in the collection, so you could test for it. So we could say if date begin is in the data dictionary, then print that out. All right, so just cursory glance, we can see dates, but we also see 0. So maybe it's set to 0 if it doesn't have a date. So we could also test that. We could say if date begins does not equal 0, then do this. So now we just have dates, right? So let's let's make a list called all dates. And for each one of these, we're gonna, not instead of printing it, we're gonna append it to the list. And then we can say print, we have the length of all dates, all dates, total number of dates. So if we run that, we can see it's going through and it went through all 11,000 or however many thousands of files there are and found 6,562 dates, right? And so this is way better than having to ask the API to return all that data for each time you want to ask a question, right? So now you have all the data just sitting on your hard drive, and you can, modify your question, change it, and update the code to do whatever you want. You don't need to wait for the internet server to send you the data. You have it all locally cached now. You can do whatever you want. So let's just answer our final question here. What is the average date for these mediums? So we can leave that there. So to find the average, we need to know total dates is the total number of dates equals when all dates. And we could say total date value equals 0. And we could loop through all dates. So we could say for date in dates. And so then we could say total date value equals total date value plus the date that we're looping through. And then we can divide them. So we say total date, or we could print out the average. We say the average is, and we say the total date value. This is just simple averaging, right? Divided by the total number of dates. And we should see a result. I messed something up there. Total number of dates. Just print this. Oh, I divided it by the same thing, which would make sense, right? If it's equal to 1. So total date value divided by total number of dates. Let's see what it says. Right, so the average dates for these collection items is, the early 1900s. So this kind of gives you a sense of how you could start working with this sort of managing JSON files or any kind of file really locally on your computer, so you don't have to keep talking to the server or the API to get the data back you want to work with. So this is a really good approach to thinking of how to split up your project into like different sections, right? So we have like a gather data section, then we have the analyze section, and writing scripts to fit those kind of use cases. Okay, so in this example, we're going to do the same idea where we're looking for we have a resource or a bunch of resources on the server, and we want to kind of aggregate all those pieces of data, and we want to do something with them later. We don't want to keep talking to the server and asking over and over again, for the same resources. We just want to have like a collection of them and analyze them and do something with them. So in the previous example, we had an API. And so we just talked to the API, we downloaded all those items, and we have them in our directory as JSON files, and we were ready to go, right? In this example, we're kind of going to mix those two ideas. So in this example, the American Archive for Public Broadcasting, we have a portal, basically a portal of items. In this case, it's audiovisual items. And if we do a search, we can see one of these items. And basically, what we want to do is, there's 60,000 items in this portal, and this is a web portal, right? But if we go into one of these items, this site actually has a feature where, here's the description of the item, and you can watch it, etc. But if you, in the URL, if you add a .pbcore to the end of it, it will actually return not HTML, but it will return an XML metadata file of the item you're looking at. So you can imagine this is super useful if you wanted to analyze the items. You could just look at all the PB_Core files, the XML files, and PB_Core is like a derivative of Dublin Core. It's specifically for media assets. So what we can do, right? So now we have a problem where, okay, so we can get the metadata in a machine readable format in this XML file, but we don't have there's not like a GitHub directory or a GitHub repo with all 60,000 XML files. So what we need to know is what are all the item IDs, and then I can request all the different PB_Core files for all those items. And so now here we have a situation where we have a list of all the items in the website, and then we know how to get the PB_Core files from that, but we need to build a list of all the items first, so then we could download all the XML files, right? So now we're in a situation where we kind of have to do web scraping and some sort of like data work, right, to pull out the XML files. So the first thing we need to do is understand how the website works, right? And so we did a blank search and it returned all of the items, so that's great. And so if we click the next button, we can see that we just want to look at the URL and see what changes. So we can see when we hit next, the URL kind of added a page equals 2 option. So if we just imagine if we change this to, page equals 6, what happens? And it works. Then we can see over here, we can change the other options here. We can say how many per page do we want? We want 100 per page, so let's say. It's taking a minute to process. But we can see that it added per page equals 100 to the URL, and it went back to page 1. So now we know that there's 60,887 things divided by 100. You know how many pages you have. So the goal here would be let's write a script that goes through all of the pages and pulls out each one of these IDs. So then we could go back and pull out the PB_Core XML file for each one of them, right? All right, so what we need to do is web scrape the search result page and increase the pages, per loop or something to load up each page results, and then web scrape the addresses, right? So if we inspect this, we can see that this A link has the link to the item we would want to pull out, and then we just need to add the .pbcore to the end of it, and it will turn into XML instead of HTML. So basically, we just need to look for all these items and pull out each one of them, and then we'll be all set. All right, so let's get started by making a script, right? So we'll go back to my downloads directory, and we're going to make a directory called this is called American Archive of Public Broadcasting, so we'll call it AAPB. All right, so we're going to make a new script here called download, or how about get links. And so we know that we're going to be talking to the internet, so we need to import the request library. And we know we're going to be working with Beautiful Soup because we're going to be parsing HTML. So we're going to import BS4 from BS4 import Beautiful Soup. Right. And so we need the URL pattern. So we have the URL base here, and we know that this is basically the base of it. And the only thing that's going to change is the page. So we can change this into a payload params setup, so we don't have to kind of like build a URL each time. I'm not really sure what this is doing here, so let's see if we take it out. Do we have the same results? No, we don't. So I'm not sure what this is, that specific um, sequence is doing. So this is a special escape sequence. So I think it's saying F equals here. So let's look up this escape sequence and see what it does. So that's bracket. So let's look at this link here. Yeah, so I'm not really sure why it's doing, what's passing there. So this is kind of a weird URL situation. So we might just kind of choose just to modify just the URL itself. And so if we take out this page equals 1, we could just add it on to the end. So for each one, we could say page equals 2, 3, 4, 5, etc. for how many pages we want. So, normally we would probably do something like parms, and then make a key value pair. So this would be like page and 1, right? But in this case, we're just going to directly modify the URL because I don't really know what this is doing, and it needs it to work. So we're just going to leave it in there. All right, so what we're going to do next is just see if we can get the first results of page back from the HTML and just try it, right? So we're going to say request dot get, and we're going to ask for the URL. And before we do that, we're going to say URL equals URL plus page equals 1, right? And let's just print out the HTML that it gets back. So Python 3 get links. And so we're hoping to see basically the search result page. So we're hoping to see, what is poverty? What's new? Self-encounters. We want to see that these are on the result list. And you can see this is taking a while because that's kind of like the big deal to the site specifically is trying to download 100 of the first result set of 60,000, right? So I'm just going to do a control F in my terminal here and see if we find it, right? And so there it is. What is poverty? So our expectations of what the URL does is matching the reality of what the server is sending us back based on the URL. And so what we need to do now is find this href, right? Because this has the link that we want. And so we can kind of see that there's some possible ways of doing this. So there's like a thumbnail here collection that has the A link in there. And then we have image here. And then we have an article class. This might be the best way of doing this, right? Because you don't know necessarily if they all have images or thumbnails, who knows? But they probably all have this article, and then this A link inside of the article has a full link to the item. So let's use Beautiful Soup to find the article and then find the A link inside the article. So what we're going to do is say soup equals Beautiful Soup, and we're going to say pass it the text, and we're going to also tell it to use the specific parser. We're going to tell it to use the HTML parser because it's HTML. And then we're going to ask this Beautiful Soup object to find all the articles. So we're going to say articles equals soup dot find all, and we're asking it to find the article element where the class is going to be equal to column MD9. So we'll say where class has column MD9 in it. So now this is going to be all the articles, and we actually want the first A link inside the article. So we'll have to loop through all the articles. So we'll say for art in articles. We could say, we'll spell it full article in articles. And then we can say A link equals, And since this is another beautiful soup object, we can use the find. Instead of find all, we can use find. So we'll just find the first one. And we'll say find the first A link. And then let's just print out the first A link that it finds in the article element. So let's run that and see what it does. And again, you can kind of see why you necessarily would want to have your own cache of this, right? Because the server takes so long to respond back to your queries that if you kind of had a bunch of questions and you want changes those questions over time, adding new stuff to it, taking stuff away, you wouldn't want to have to ask the server for the data each time you wanted to ask that question. You want to have a local version of it. And so it looks like this is working, right? We have the articles, and we'd want to test here to see how many things here. I can just do a find in my terminal and see that we found, I'm not sure how many, but there's probably, you would assume 100 here, right? So what we want to do is we don't want the whole element, we just want the href of it. And so this is an element, an attribute. So we can just reference attributes like this. And so what we want to do is put this somewhere, right? So let's make a new list, and we'll append the A link href into that new list. So at the end of it, we'll have a big list of items, of URLs. So let's just see if this works. And let's just write this out while we're doing this. We'll say JSON dump. And so we got to tell it what to dump, the URLs, and where to put it. And so we're going to open a new file called all URLs.json for write, and we'll just ask it to indent it. All right, so let's try to run it again. And so if this works, what we want to do is set up a loop that will go through all of the pages, not just the first one, and modify that URL each time so that's the next page works. All right, so it's good that we tested it before we tried it on all of them because we got an error here on 17. This says this doesn't exist because I forgot to add an S. So let's try it again. And so I was saying if we have a loop that loops, 60,000 times or however many pages, 100 divided by 60,000, then we will have all of the items, basically all, or at least all the URLs. All right, so it's also good we ran it again, right? It says JSON not defined because we didn't import JSON. So this always, demonstrates why it's good to test it on a sample, right? Before you try to run it for all 60,000, because you wouldn't want it to loop, 6,000 times and then get to the end of it and be like, oops, JSON's not defined, and then crash and you have to run it all again. All right, so that worked. Let's take a look at the file to see if it looks right or it looks good to us. So we'll sublime all URLs. And this looks pretty good. There's 101 lines, and that means there's 100 things in there. So that's 100 items from the first page. All right, so now what we want to do is put this inside of a loop, right? And so we could hard code the number of times we want to loop because we know that there is 6,800 pages divided by 100 per page would come out to be 608.87. So we just round that up by 1 and say 609 pages, right? So we'd say we need a counter somewhere. Start to 1, and then we'll say while counter is less than or equal to 609, then do this, and the last thing we wanted to do is increase counter by 1, right? All right, so now inside of this loop, though, this is going to loop 600 times. We just want to move all of our code inside of there. And we could put this at the very end, but I'm just gonna leave it in there just so it, we don't have to wait for it to run 200 times before we go to the next step. We could just theoretically say that it would run. All right, so here the URL is adding the page one to the end of it. So all we need to do is change this to add the counter to the end of it instead of just a static one. We want to make sure that's a string if we're going to add it into there because this is a string, so this needs to be a string. So it will say 1, 2, 3, 4, and add it to your URL. And the rest of this can all say the same, right? Because it's just, we'll delete the print statement, and maybe we'll print the URL that we're on just so we can see where it's at. But the rest of it's the same. It's just going to go through, find all the articles, pull out all the A links, add them to this big list, and then they write the list out at the end of that. So the list will grow each time. So there's a little bit of duplication of work because it's going to write this first 100 out, 600 times, but it's such a kind of minimal operation that doesn't matter. All right, so we're going to run this. We probably run it for 600 pages because that would take a long time, but you theoretically could, right? So we'll run this for a few pages so we have some data to work with and then start working with that in the next step. All right, so I let it run for 6 pages, so that's 600 of results. I broke the script and canceled it. So we should have 600 items, and if we go to our list of items, we can see how many we have. And we have, around 500. So it was on the 6th page, so it didn't finish downloading 600, but we got 500 to work with. So that's a good enough start for us. So now, we'd want to kind of leave the script behind and make a new script because we have a different process here. So we can sublime a new one. We'll call it getxml.py. And so now this one is going to open up that list that we just made and then download those PB core files for each one, right? So we know we're going to deal with the internet again, so we need to import requests. And we know we're going to be dealing with JSON because we saved the file as JSON, so we've got to save import JSON. So the file name that we saved all those links in is called all URLs. So what we can do is just say, okay, data, or we can say all URLs even, equals json.load, and we want to tell it to open this file called all URLs. And that's all you need to do. So now this will have become that JSON dictionary, or JSON list. And so now it's a Python list of strings. So we could say for URL in all URLs, print URL. Let's see if it works. Oh, and you have to spell open right. All right, so that works great. So we know that this is a URL, but it's a relative URL. It doesn't have the full thing in front of it. So what we can do is make sure we have the full piece of it in front of it, right? So we know that this is the root of the URL. So what we can do is say, okay, have the URL equal this plus itself, right? So now we'll be dealing with the full URL, not just the piece of it. And we actually know that we don't just have that, we have the end piece at the very end. We want to add PB core. So now this is the full URL, not just to the web page that this is, but to, oh, we have a double slash here. So that wouldn't work, right? So we want to make sure there is a slash in the URL variable because they begin with a slash. So we just want to take the slash off of the base URL so it doesn't duplicate it. So let's run it again. And so now we have this full URL here, and it's not a URL to the web page, it's a URL to the PB core file, which is the XML file. And let's just see if it works. Yeah, it worked great, right? So here's XML returned. So now what we need to do is download these someplace, right? So let's make a directory. So I made a directory XML files. And you can imagine if you had 60,000 of these, that something could happen in that case of running this 60,000 times. Your internet could go out, some error might pop up. something like that. So we'd want to make sure when we write this next step that there's a way that it can resume where it left off. It doesn't just fail, right? If it didn't work. So what we can do is basically do a check, right? So we know we're going to put all the files into this directory, XML files, and we can think of what we're going to name them, and we're probably going to name them this, right? Because this is the file name. So it will be the CPB or whatever long identifier plus PB core, and that will be the file name for each one of them. So let's just do that per, and then we'll come back to writing this second piece I'm talking about. So we know that we're going to use requests again to ask for this file. So we'll say r equals request.get, and we're just going to simply point to the file or the URL of the PB core file, and then we'll say we're just going to write it out. So we'll say open. Oh, that's right. We need a file name, right? So before we do that, let's print out the URL again before we start making it into the full URL. Oops. All right. So here's the data we have coming in, and then we have the full URL. So actually what we could do is if we just chop off this first piece, then we'd have the file name, right? So let's do that. So we'll say the file name is going to be equal to the URL, but we're going to replace a piece of it. We're going to replace this first piece with nothing. And then let's print out the file name. Right, so now we just have the URL and we have the file name. So now we have a place, a file of what we can call it, stored in our variable there. So we can now make the request, right? So we're going to get the URL. It's going to pull back the data, and we're just going to say with open, and we have the file name that we want to use, but we want to put it into the XML directory, XML files directory. So we're going to say XML files / and then add that file name to it. And we have to make sure to add it as write mode, so it writes it out. And we're going to say as out file or something like that. And then here we're going to say out file dot write, and we're just going to write the data that came back from the request, the body of it, the text of it, right? So if we ran this for a few rotations here, you can see it's chugging along, right? So it would have to do that 60,000 times. So I broke it here, and we can see in the XML files directory, there's a few of them that it worked. So what would be really cool is if we could write a script that checks to see if that these are there, and if it is there, then skip it, right? So what we can do is use the Glob module. And so we talked about this in the previous example, the Glob module, and we can ask the Glob module to find all of the XML files. And so we're going to say glob.glob and find those in the XML directory. And they're going to be called star.pbcore, right? So that's the file name as star wildcard, and this could be pbcore. And so let's comment this out for now. And let's print this, what it says. Right, so it returned these file names here. So what we could do is we could write a new variable called already done or something like that and make it a list and loop through these files. So we could say for already done file in the list of them, right? And we notice that this is going to have the XML files and this, but maybe we just want the file name, so we can just chop off this piece of it. So we could say already done dot append, and we're going to append the already done file name, but we're going to replace a piece of it. We're going to replace this first part with nothing. So at the end of it, we should have a list of already done files that were finished. Oh, you have to add the actual method you want to use. We're going to say replace, right? So we're going to replace with the already done file name, we're going to replace that little prefix of the directory name off of it. So we just have the file name itself. Right, so now we just have a bunch of file names. And so these are the file names that are finished in the directory that we just saw. So if we have a list of all the file names that are done, then we could use that to our advantage, right? If we need to pick up the script from where we left off. And so if this directory was empty, this already done list would be empty too, because there's no files done. So there's no really downside of doing this, right? So the last thing we need to do is to check to see if the file name is in the directory before we make the request. So we could say if file name is not in the requests or already done files, then make the request. Otherwise, we'd want to print something like skipping and then with the file name, right? So we have a list of file names that are done, and then we have we're going to build the file name here, and we're just going to check to see if it's in the list. And if it is in the list, then we're going to skip that one. So now the script has become much more flexible, right? Because it can stop and start wherever you need. You can imagine if this was something that was going to take many, many hours, if something could go wrong, or you might have to stop the script. So it's nice to be able to pick it back up wherever it left off. So we should see it skipping the first few of them. Yep, so we can see there, it's skipping, and then it's just going into downloading all of them. So we're gonna let this run and come back, and when it's finished downloading these 500. All right, so it finished running for the 500 that we had the pages for. So if we look in this directory, in the XML files, we can see they're there. We could open one of them if we wanted to. All right, and so here's has some metadata, or has all the metadata for these records, right? So then we want to make a new script here that does, so we have get XML. So let's do one called parse XML. So now this one we want, since we have a directory full of files, we want to open them, right? So we're going to use Glob again to import stuff. And since our XML files, we're going to import the XML etree element tree library to work with them. And we're going to import that as ET. All right, so let's first loop through all the files that are there. So we'll say with, so we'll say for glob. So we'll say for file in glob.glob, and we'll say find all the XML files directory and find all the pbcore files. And let's just print the file name, see everything is working. So let's run this. Python 3 parse files. No element named, sorry, I spelled it wrong. Element 3. Let's try again. All right, so there's all the file names. So now we just want to try to use element tree to open each one of these files. And to do that, we say tree equals et.parse and the file that we want to open, which is stored here in file. And then we need to get the root element from the tree, get root, and then we could say, print root, see what it says. All right, so it's working. It worked for all of them, right? Parse all of them. So we can say print root.tag, I believe. Yeah, and so this is the tag name. So it's the pbcore description document. So if we look at one of the examples here, that's this root element, right? Everything lives underneath of there. So say we wanted to loop through all the children elements. We could say for child in root.children. And let's print the child tag. All right. Okay, no children. So that's going to Google this really quick because I don't know how to do this. Get children. Let's see, children. All right, so maybe find all. So find all the children, regardless of what they are. Okay, that doesn't work either. And eTree. All right, so we're just trying to figure out how to iterate through the children nodes. And we'll say, okay, so you just say for item in the root. Okay, so I had that backwards. So we just say for child in the root, and then we print the child tag. Let's see what it says. Okay, so there is all the children tags. So we could test this and see if we wanted to pull out one piece. So say like we want to pull out the asset date. So that's the tag name, but the full name is actually this whole thing with the namespace. So we could test that in our code and say if the child.tag equals this whole thing, then print it out. So we should only get the dates here. Yeah, so there's the date tag, and then we want the value inside of it, not the tag name. Let's just see what it says. Okay, so no value tag, no value element, maybe text. Yeah, so there's the date for each one. So if we wanted to do the same thing we just did with the API example, looking for the kind of average date for everything in this list or list of records, we could use the year date, right? So we could split that up. So we could say split on the dash and take the first one, 0. So then we would only get the year. And then we could say, okay, year equals that. And we want to turn it into a number, right? So we'll say int. So it will become a number. And that still works. And then we could just do the same thing we did before, right? We could say like all dates equals this, and then total dates equals 0. And then we could say total dates equals total dates plus date for the year. And then we could say like, we could just make this a counter too. We could say all dates count. We could say all dates count equals all dates count plus 1. So when we're done, we could say print the total dates divided by the number of them that there are. We should see the average here for all the assets. Yep, so most of them average from being in the late 50s, right? So of course you could, once you have this going and you can parse this file, you can do whatever you want with any of the metadata, similar to the JSON stuff, except this is just XML. So in this kind of example, we saw how you can use web scraping to kind of get a list of resources and then use requests to download all those resources. And we did a kind of a nice thing where we kind of use Glob to look ahead into the directory to see what files we already had. And then if we were, stop the script and start it again, it would check that directory first and then skip the ones that we had already downloaded. And then this final script where we can actually loop through all of the records and do something with them in bulk. So again, this is a great way of working because you aren't relying on the server to send you the new data each time. You just have it locally and you just run your scripts really quickly without having to do all those requests again. So I think that's it for this video. Thanks for watching, and I will talk to you later. Bye.